Welcome to Rolo Robotics, where we are building the world's first stable monowheel robot. What if we have 4 times less wheels than a conventional vehicle and 4 times less production cost? That was the driving question that defined the form factor that you see right here. We are going to our testing field, stress test the robots and teach the robot to drive autonomously. China has been trying to build a stable monowheel for the past 7 years, so far unsuccessfully. NASA has been trying to achieve the same with local universities in the US. A monowheel moon rover, a robot that can glide over the moon surface that doesn't get stuck, but the problem is that no one had solved the stability paradox.
Everybody knows that the one-wheeler is not stable because it has only one touch point to a ground, so there's not a lot to push against yourself into.
If you don't have stability, then at speed, the driving becomes almost impossible.
If you drive faster, it starts to oscillate until it becomes absolutely unstable and just falls down.
And this has been the problem that many companies and countries have been trying to solve before, how to make it stand upright and drive in a stable manner.
Let's say if we take a wheel and we make it rolling, it keeps itself upright. Yeah, it doesn't fall down. It doesn't fall down because all the mass that has in a wheel, it rotates. And we have an extra mass, like batteries or payload. So unfortunately for us, the rotation of the tire itself is not enough to stabilize it. So we need to add an extra gyroscope that rotates the same way. This is one of the models that we have, a disc of a gyroscope that spins very fast inside the robot.
Traditionally, gyroscopes are used horizontally, but we placed it vertically.
It stabilizes it because it adds extra moment of inertia to our machine. Basically, it rotates the same as the wheel rotates. It keeps it nicely steady and stable, and it damps the oscillation. But the trouble is that it doesn't allow to turn the vehicle. If it spins in this direction, then it would be very difficult to tilt it or turn it. It would prevent the vehicle to turn itself. And the very simple solution is that instead of trying to turn the vehicle, we try to tilt it. We force it to the side. We try to tilt it. And once we do that, the precision of a gyroscope starts to rotate on the reciprocal axis like this. And that makes our vehicle to turn. So we have 2 in 1. We have a stable vehicle and we can turn it.
And in this way, we have achieved stability and solved the stability paradox. It doesn't rock, it doesn't wobble, and once you have stability, everything is possible. Now you see what I mean by the moon missions. This is a very similar environment.
Yeah.
I was watching Star Wars and always been a fan of the very futuristic robots in Star Wars. So some of the vision actually came from, looking at the BB robots in trying to see if it's possible to bring it to life. Human labor is getting more and more expensive. When human labor is going up and up every year, robotics are able to show the opposite line of costs decreasing year over year. And this is exactly what Rollo is doing, providing a more cost-efficient platform to help with human labor shortage, workforce shortage, and reduce operational costs.
Maintaining and running a human security team along with vehicles can cost around 500,000 euros a year. We can provide the same service for less than 100,000.
At Rollo, we aim to be one of the first and leading technology companies whose robots are widely used in everyday critical infrastructure security. Everybody knows what digital AI is capable of, right? But this is now the next frontier, physical AI, where the robot is making its own decisions and in the end will be able to follow commands in every language to complete the mission. All the intelligence, the motors, gyros, IMUs are all inside the wheel. And when all the important bits and pieces are inside a wheel, we can start playing around with the top application and top part. Critical infrastructure that requires 24/7 surveillance is all manual, like airports, ports, energy manufacturing facilities. We have tens of millions, 28 million security guards out there in the world, but very little automation in security surveillance.
The robot autonomously patrols the perimeter that we have agreed upon and detect perimeter fencing irregularities. Once we detect a threat, we will shoot the message off to the security team, and the client will deploy their security team to take care of the threat. So the idea of the robot is really not to replace any security teams, but to really complement people and to provide them with tooling that will make them much more effective.
Essentially, Rollo is a land drone. We all know what drones up in the air can do. When you think about Estonia and the fact that we are bordering Russia, which needs 24/7 surveillance, we all know the threats and macroeconomic situation that is, unraveling right now. We have a vision where Rollo will be deployed near the border, on the battlefield, mines, all areas where, robots are dispensable, but people are not. The robots don't sleep, they don't take breaks. They work 24/7 throughout the year in various weather conditions. We have created a true workhorse.
Europe can build. What's missing is her story. For decades we got taught to fear the future, not build it. That's why we are making documentaries about the engineers, scientists and founders building the future. Here in Europe.
So Rollo can be considered as a platform. In this configuration we have the security robot. We detect animals, we detect humans, vehicles. We can read license plates, detect fires in the buildings. Setting up the robot for autonomous operation is actually super easy. We don't need to create 3D maps of the cities. We record a very simple base route that it can start following immediately. We have a 360-degree view around the robot with stereo cameras, so it understands everything that's happening around it. You only have to drive through the area one time, record the base map, and the next time the robot can already start autonomously following it. The robot itself is actually very simple to build. We have less components than traditional vehicles. What we are machining right now is the engine mount, the motor mount, where we attach a beam and the electric motor. And it's all CNC machine. There is no such tire available on the market, so we had to design and manufacture our own tire. It's like a sphere, very thin, but strengthened by carbon fiber beams. What that tire design allows us to do is place the battery at the very bottom to have as good center of gravity as possible. When the gyroscope is not running, it's not spooling, then the vehicle is not falling over. It's stable even when it's switched off. One wheel has only one touch point with the ground, meaning that we have very low rolling resistance, thus very high energy efficiency, which in turn means that we have a very long battery life. In hardware manufacturing, there are no shortcuts. We can't force speed in the R&D environment. Rollo Robotics was born out of our previous robotics businesses. Our first company was Cleveron, which became the pioneer in the smart locker industry. Our second company had a very similar name, Clevon, which was autonomous delivery vehicles, which then became the first autonomous vehicle without any drivers driving on the public roads in Europe. Both those businesses were acquired by investors, which gave us the freedom to start pushing boundaries in the monowheel robotics sector. We gave ourselves a limited budget to see if it's actually possible or not. Everybody thought that building a stable monowheel is an impossible task because no one had done it before. We decided to allocate $500,000 for bootstrapping, and we had to make it or break it during 6 or 7 months. In the beginning, we started building a very small robot. We always faced the same problem as China or NASA were facing, which was that the robot was not stable. It was rocking and really wobbling a lot. It took us a lot of experiments, switching gyros, switching electric motors, trialing with different algorithms.
In the beginning, it seems very simple, but once you start doing it, you realize that it's very, very difficult.
To really find the breakthrough. So I think we failed a lot. The first few months were all about failing and learning from the mistakes.
We were trying all sorts of different things, all sorts of constructions.
We discovered the breakthrough almost by accident.
Just on an ordinary day, we tried yet another version of it.
I think it was our 5th or 6th prototype.
Accidentally, it's been the wrong way. So we thought that no, it doesn't work. It doesn't drive. Then we suddenly realized that oh, that works.
Started working driving backwards.
We just need to reverse the direction of rotation.
This is one of the earlier ones, probably 4th or 5th version. This is the first one that was really like rock solid and achieved the necessary stability. The discovery of the now patented methodology how to build a monowheel almost came by accident, but it was a result of rapid prototyping and testing. I could say that this prototype maybe cost a few $100,000, right, to achieve to achieve the stability. So it's pretty precious. The purpose of the earlier prototypes was to maximize like real life experience, collect miles, break stuff as early as possible, and with the current model here, we've been testing the limits of the prototypes and attaching safety beams so that it doesn't fall over. It might look robust, but it's functional. So the whole philosophy is that make it exist, make it good, and eventually make it great. If you stay in the lab environment too long, there's a chance that you become like a research project. I think this was version 7 or 8. Just to demonstrate like the stability, we can kind of push it from all directions. It doesn't really fall over. This one has been pushed to the absolute limit and it has found its limits. It's falling apart. As with any prototype, someday it works and suddenly it won't work, it breaks, as you saw just now. So it's this continuous loop of trial and error and fixing things. This one has seen quite many miles. It's been used actually since 2025, so it's seen a lot. I think we should give it a good retirement very soon. For the younger generation who's about to embark on the robotics journey, it's quite universal skill. We have done lockers, we have done autonomous vehicles, and now monowheels. So it means that you can very easily select, the area, the product to work on. So learn robotics and you can do pretty much anything. It's like a superpower. Right now is the best time to start a robotics company. You have tools, both digital and physical, which even didn't exist a few years ago. It's relatively easy to get going and build your first robot. Put together a small team and just try to build your first product. It's easier than ever before. As time goes on, the possibilities to use Rollo will be endless. And not only will they do security surveillance, but everybody will start seeing Rollo being used by cities, in parks, in public environments, doing all kinds of activities, all kinds of work. There isn't enough young people that want to, become security guards or do any essentially manual work. Robots can step in, alleviate the pressure of finding and retaining, workforce. Goal was to develop the world's first stable monowheel platform, but it turns out that we accidentally invented a whole new vehicle class. So the idea we have is not only to keep it siloed for our corporate customers. We want to give access to developers, technology enthusiasts to take what we have built and improve it. You can develop your own top applications, your own use cases for Rollo, gardening or for snow shoveling. I can imagine people building arms on the robot that can pick up trash or pick apples from the trees.